brief moment in October, Nvidia was the first company ever to reach a $5 trillion valuation, thanks to its original gaming engine, the GPU, becoming king of AI chips. So what exactly optimizes a chip for AI?
A GPU, in this case, was really purpose-built to deliver parallel programming. Because when you think about rendering an image or a scene, you need to calculate all those pixels at once. And so AI really lends itself to taking advantage of that capability.
To understand how GPUs became synonymous with AI, let's go back to 2012, to what many consider AI's big bang moment, AlexNet. It was a new, incredibly accurate neural network that obliterated the competition during a prominent image recognition contest. Turns out the same parallel processing used by Nvidia GPUs to render lifelike graphics is also great for training neural networks, where a computer learns from data rather than relying on a programmer's code.
The researchers took a GPU and said, I'm going to hack it to get it to expose the parallel computation capabilities to unlock that performance for the deep learning use case.
While AI workloads are usually accelerated on a GPU or custom ASIC, it still often needs a host central processing unit, CPU, like the Grace in Nvidia's Grace Blackwell server rack system. But while a CPU has a small number of powerful cores running sequential general-purpose tasks, GPUs have thousands of smaller cores, more narrowly focused on parallel math like matrix multiplication, used to process multidimensional data structures known as tensors. This ability to perform many operations simultaneously makes GPUs ideal for the two main phases of AI computation, training and inference. Training is teaching the AI model to learn from patterns in large amounts of data, while inference uses the AI to make decisions based on new information, the way AI shows up in everyday applications.
Whether it's the way you buy your coffee on your Starbucks app, or how you interact with Salesforce for work, or speaking to us through our earpods, that is being done through inference.
Nvidia sells its GPUs directly to AI companies, like in a recent deal to sell at least $4 million to OpenAI, and to foreign governments, including South Korea, Saudi Arabia, and the UK. It also sells GPUs to cloud providers like Amazon, Microsoft, and Google, who go on to rent them out by the hour, minute, or second. Nvidia also has a GPU rental program. Today, systems that can handle AI workloads are in such high demand, one of these 72 Blackwell server racks sells for around $3 million. And Nvidia told us it's shipping 1,000 each week.
And for Nvidia, they're looking to sell the entire system, not just the chip, because when you think at that system level, you get more efficiencies in terms of speed and power and performance.
Of course, Nvidia isn't the only one making rack-scale GPU systems optimized for AI. Its top competitor, Advanced Micro Devices, AMD, has seen major gains with its Instinct GPU line, and major commitments from OpenAI and Oracle. A big difference in AMD GPUs is that they use a largely open-source software ecosystem, while NVIDIA GPUs are tightly optimized around CUDA, NVIDIA's proprietary software platform. NVIDIA says its next-generation Rubin GPU will be in full production next year.
This is just an incredibly beautiful computer.
Although an AI data center is different, AWS has been building data centers for its millions of cloud computing customers for nearly 2 decades. And Infrastructure Services VP Prasad Kalyanaraman has been at Amazon that whole time. He sat down with Sigalos in Seattle.
When you want to build some capabilities for Gen AI, which are unique to Gen AI, like the network, or for instance, liquid cooling and so on, those are additions on top of foundational capabilities that we built over a long period of time. And that's what is unique about us, and that's why we're able to build at the scale that we are able to.
Speed and scale are key as Amazon joins the crowded race to build data centers for AI compute. Meta's 2-gigawatt Hyperion data center in Louisiana and OpenAI's 1-gigawatt Stargate site in Texas are two of the biggest that are being built now.
Many providers of that talk about gigawatts of capacity, but they don't tell you when they're going to get to gigawatt scale. What we have with Rainier is a real thing, which you've seen physically as well.
But what else sets Amazon's apart is it's filled entirely with its own in-house custom AI chips.
Behind me right now, they are working on delivering these towers. 2 of them together is going to make up one Ultra server. And inside of that is 64 AI chips. These are Amazon's own custom Trainium 2 chips. And what's especially interesting is there are no NVIDIA GPUs in there.
Amazon's been designing its own chips since 2013, starting with a specialized chip called Nitro. It bought Israeli chip startup Annapurna Labs in 2015, where we got a tour. And by 2018, had its own ARM-based server chip, Graviton. Its first AI chip, Inferentia, came in 2019. Amazon launched Trainium 1 in 2021, and Trainium 2 came out last December. AWS chips have one main advantage: keeping down costs. Amazon CEO Andy Jassy said in July that Trainium 2 offers 30 to 40% better price performance than rival GPU instances.
Availability also, like there's massive backups for Nvidia chips, and if you can get chips faster and not have to wait online for Jensen to give you what you need, then you could get working faster and be in much better shape.
Trainium chips are less powerful and simpler than Nvidia GPUs. But Amazon says by fitting twice as many in each building, it can boost compute power and keep electricity and cooling needs down.
When you're able to control the stack all the way from the lowest layer of the infrastructure, you're able to build the right set of capabilities that these model providers want, right? You don't need to add all the other capabilities that you don't need.
Some say that Trainium 1 and Inferentia 2 instances haven't been as competitive for Gen AI training due to weak hardware specs or poor software integration. What do you say to those specific critiques?
Sure. I fully admit, Trainium 1, it was our first generation chip, and that absolutely was a learning chip, both from an architecture perspective as well as a software perspective. And Trainium 2, which is where we're at now, and then Trainium 3 is where we're quite excited about our cost competitive nature out there in the market.
So, okay, I know you love NVIDIA. Talk about, your view of NVIDIA, AMD, TPUs, ASICs, and how do you think sort of market structure shakes out there, competitive advantage that the various players have?
Yeah, I think it is really, it's a fight between NVIDIA and the Google TPU. And then something that I don't think is broadly appreciated is the extent to which Broadcom and AMD are effectively going to market together. NVIDIA is no longer just a semiconductor company, as I'm sure you'll hear from Jensen tomorrow. It was a semiconductor company, then a software company with CUDA, now a systems company with these rack level solutions, and now arguably, a data center level company with the, level of architecting they're doing with scale up, scale across, and scale out, scale across networking. So the networking, the fabric, the software, it's all important. And what Broadcom is saying to companies like Meta is, hey, we will build you a fabric that can theoretically compete with NVIDIA's fabric, which is a mixture of NVLink and either InfiniBand or Ethernet. It will build it on Ethernet. It's going to be an open standard. And hey, we'll make you your version of TPU, which, by the way, took Google 3 generations to get working. And you know what? If your ASIC isn't good, you can just plug AMD right in. But I personally believe most of those ASICs are going to fail, particularly if it's
in the fullness of time, like over a period of time, or in the fullness of time?
In the next 3 years. I think you'll see a bunch of high-profile ASIC programs canceled, especially if Google starts selling TPUs externally, which has been all over X. And then, who knows exactly how that would work? Because if you're Anthropic, it's just rumored Anthropic wants to buy tens of billions of TPUs. If you're Anthropic, maybe you don't want Google seeing your secret sauce, but there's ways around that. So I think this is really a battle between Google and its TPU, enabled by Broadcom for now, and Google can take the TPU away from Broadcom whenever they want.
Yeah.
Now, they can't do the Ethernet networking that Broadcom is doing, but they control the TPU. So it's really Google and the TPU versus NVIDIA, with Amazon, like that's a very talented team, arguably the most talented silicon team at any hyperscaler, the Annapurna team. Like I think the Trainium 3 will probably be a much better chip than the Trainium 2. It took Google 3 generations to get the TPU right. And then AMD will always be kind of the second source, and you need a second source.
We don't play that.